Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about the isometric projections. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now today we are going to discuss about the isometric projections of a cube and few more combined solids which will be having the common element as a cube over there. So first of all, we are going to start with the discussion regarding the construction of the isometric projections of a cube. Thereafter, we will be picking up the construction of the combined solids, and the first one of these will be the isometric projection of a sphere resting centrally on top of a cube. Then the third one, that is the isometric projections of a square block resting centrally on top of a cube. And finally, we are going to pick up the construction of isometric projections of a cone which is going to be resting centrally on top of a cube. So all these you see combined solids, they have one common element, that is cube will be involved over there. So that is why we have clubbed all of these combined solids into this particular lecture discussion. Now first of all, let us start with the construction of the isometric projections of a cube. So before we start with the construction of isometric projections, we need to draw the isometric scale, and once we draw the isometric scale, we have to convert the edge length, that is 40 millimeter, which was the true length of a cube. This edge length has to be converted into the isometric length over there. Now we know that we have a cube available with us and we have to draw the isometric projections of the cube. So it means that all the three faces, front face, side face and the top face of the cube, will be shown in the isometric projection simultaneously, right? So all these three faces, they will be shown along the three isometric axes. So this is our x-axis, this is our z-axis of the isometric projections. So both the x-axis and z-axis, they need to be constructed at an angle of 30 degree with respect to the horizontal baseline or the horizontal ground line. So we'll be first of all drawing the horizontal baseline or the ground line and draw x-axis at an angle of 30 degree and then draw z-axis at an angle of 30 degree over there. So this is going to be our starting point for all the constructions of isometric projection. And in order to show the height, so this will be our y-axis that we will be drawing, right? So during our discussion over there. Now to begin with, all the edges of this cube will be of 40 millimeter length. So we have evaluated the isometric length corresponding to this 40 millimeter. So this length isometric 40 millimeter will be measured over here and it will be marked over here. So please check, on the x-axis I have marked the isometric length of 40 millimeter. Okay, so this is my isometric axis. So along the x-axis I have marked 40 millimeter edge length. Then along the z-axis also I have marked the edge length for the cube equal to 40 millimeter. Then the third, that is the vertical height over there. Now the vertical height I am going to show once again. The height of the vertical edge of the cube will be again 40 millimeter. So this 40 millimeter edge length I am going to mark on the y-axis. So on the x-axis 40 millimeter has been marked, on the y-axis 40 millimeter edge length has been marked, and along the z-axis also 40 millimeter edge length have been marked. Now we need to draw another couple of, you see, isometric lines which will be parallel to this x-axis, y-axis and z-axis. And once we are able to draw all these lines, we'll get the construction of the isometric projections of the cube completed over there. So let us do it. So this is my isometric line corresponding to the another edge which will be parallel to the isometric axis over there. So these three edges, you see, edge 1, vertical edge 2 and vertical edge 3. So these three vertical edges, they will be visible to us in the front view, right? So in the front view, we will be able to have a look at all these three vertical edges over there. Then parallel to this edge, that is along the x-axis, another isometric line corresponding to another edge of the cube has been drawn over here. Then another edge will be drawn which will be parallel to the isometric axis line which was drawn along the z-axis over there. And finally, you see the third edge which will be again parallel to this z-axis will be drawn over here. And similarly, another edge of the cube which will be parallel to this one, and this edge also will be drawn to complete the construction of the cube. Now parallel to this as well as parallel to this, so another edge or a line which is again an isometric line has been drawn to show the top face of this particular cube, because whenever we are looking at this particular cube, all the four edges of the top face will be visible to us, whereas these two faces of the base, they will be lying behind these two faces of the cube. So these two edges, they are not drawn to begin with. Okay, so we haven't drawn these two edges because the edges, they will be falling on the back side. Why? Because these surfaces, this surface of the cube and this surface of the cube, so they are going to hide the edges which are going to lie behind these two surfaces. So that is why we did not draw these two edges. But now if we have to show those constructions over there, so this is a light line which we have drawn. Another edge will be parallel to this edge which will be lying upon the base over there. Similarly, there will be another edge of the cube which is lying onto the base, which is parallel to this edge which was drawn along the z-axis. But in the final construction, you see these edges, they are not visible. And another thing, we know that in isometric projections there are no hidden lines. So the hidden lines, they are not shown. So whatever edges they are not visible, they will be shown either with the help of light construction lines, and they will not be joined over there. And unlike in the projections of solids where we used to show the hidden lines for those edges or surfaces which were not visible to us, in isometric projections there is no place for these hidden or the dotted lines over there. So any of the edges which are not visible, we can show them for the purpose of construction using a thinner line or a construction line over there. Okay, so if we want, in the final figure, if we just hide the hidden lines over there, you see this hidden line we have taken out. Okay, so this is the final construction of a cube in which all the edges, they are equal and they are equal to 40 millimeter over there, right? Now let us move on to the next, you see, question in which we have to draw the isometric projections of a sphere which is resting centrally on top of a cube. So let us go through the statement. A sphere of size 40 millimeter rests centrally on top of a cube of side 40 millimeter. We are required to draw the isometric projections of the combined solid. So first of all, we are going to draw the projections of a cube. So similar to the previous case, once again we have drawn the XY reference line over there, that is the horizontal baseline. This is our horizontal baseline, and we have drawn the isometric scale. So whatever distances will be involved, the true lengths have to be converted into the isometric lengths. Now along the x-axis, the edge of the cube 40 millimeter has been drawn. Then along the z-axis, again 40 millimeter edge of the cube has been drawn. And then along the y-axis also, we have marked the length of the cube or the edge of the cube is equal to 40 millimeter. So this is the height component. So three edges, three vertical edges, they will be visible to us from the front. So this is edge number 1, edge number 2 and edge number 3, and the height is also equal to 40 millimeter. Okay, so distance along x-axis, distance along z-axis, distance along y-axis, they are all 40, since all the edges of the cube happen to be 40 millimeter long. Then as we discussed earlier, we can join this edge corresponding to the top face. Similarly, this edge corresponding to the top face of the cube can be joined dark. But in this case, because a sphere of size 40 millimeter will be resting centrally on top of a cube, so we are not going to darken these two edges. Why? Because certain portion of these two edges, it will be covered by the sphere which is going to be resting over here. You see, once I put the sphere over here, it is going to cover certain portion of these two edges. So the remaining two edges corresponding to the top face, they have not been drawn dark. So rather the light construction lines, they have been drawn over here to begin with. Now once we have completed the construction of a cube in which top two edges we have drawn to be light, now next we can do is we can join this diagonal of this particular square face of the cube. That is, this is the top face of the cube which happens to be a square, and as we know that a square appears to be a rhombus in case of isometric projection. So these are all three squares which are visible to us, but in every case we can see this is also appearing to us as a rhombus, this is also appearing to us as a rhombus, right? Similarly, the top face over there. So in the top face, while we join the diagonals, so this rhombus appearance becomes even more apparent, but our main objective is to evaluate the center point of this particular top face of this particular cube. Now having drawn the center point, now my sphere must be resting centrally on top of this particular cube over there. Now one thing we must remember, that is, whenever we are required to draw the projections of a sphere, we may draw the projections of the sphere on the horizontal plane, on the vertical plane, on the profile plane, or on any auxiliary inclined plane inclined to HP at any given angle, or we can draw the projections of the sphere on the auxiliary vertical plane which may be inclined to VP at any given angle. So in all the cases wherever you may like to draw the projections of a sphere, you are going to get the projections of a sphere to be appearing like a circle in every projection. So that is why that even in the isometric projections, because we have already discussed that the shapes, they are not preserved, or even the angles, they are not preserved in the case of isometric projection, but this does not apply to the sphere. Why? Because you look at sphere from any angle, from any orientation, the projection of the sphere will look like a circle over there. So in this case, the projections of the sphere, they will appear to be a circle over there, because otherwise whenever we are trying to draw a circle or a cylinder in isometric projection, it will start behaving like an ellipse. We have drawn a square over here and it behaves like a rhombus over there. So this distortion does not apply to the sphere. Then what principles of isometric projections will be applicable while construction of the sphere in the isometric projection? Because it is not going to affect the shape. Shape will remain the circle over there, irrespective whichever is your point of reference of viewing the sphere over there. Now one principle of the isometric projection will be applicable here. So let us discuss that particular principle of isometric projections which will be applicable to the sphere. Now please check, we are given that the radius of the sphere is equal to how much? 20 millimeter. We have a sphere of diameter 40 millimeter. It is resting centrally on top of a cube. So this radius is equal to 20 millimeter. So if I draw this projection of a sphere, I will be getting a circle of diameter 40 millimeter or a radius is equal to 20 millimeter. So still you will say that the principle of isometric projection that you were talking about, it has not been applied. But one principle is applicable. Please see, that is what? You see, the circle diameter is equal to 40 millimeter. That is fine. The shape, there is no distortion with. But the radius of a sphere, it is a linear distance, because all the linear distances, they have to be plotted onto the true length, and the isometric lengths, they need to be obtained over there. So in this case, what we have to do, let us say this is my circle. So in this circle, I have a linear distance which is equal to radius of this particular sphere. And how much is the radius? Radius is equal to 20 millimeter. Now I'll mark 20 millimeter as a linear distance over here. Just see, I'll be marking 20 millimeter on the true length and transfer it onto the isometric length. This will be my isometric radius, and this value will be 16.4 millimeter. So 82% of 20 millimeter will be 16.4 millimeter. So the principle of isometric projection which is applicable to sphere is this one, that from this center you mark a radius of, please check, you mark a radius of 16.4 millimeter, because radius of a sphere happens to be a linear dimension. So all the linear dimensions, they will be foreshortened or they will be reduced while we are trying to draw the isometric projections of any given object. So the radius has been reduced. So this radius I will be marking as 16.4. So this will be my center point for the construction of the circle. But when I start construction of the circle from this particular point O, now I cannot draw the radius is equal to 16.4. It is only that this linear distance has been plotted over here, and then I'll keep my compass needle over here, open the compass equal to 20 millimeter. So once I open the compass, radius is equal to 20 millimeter, and draw a circle of 40 millimeter diameter, because sphere will appear to be of the same size, no reduction in the size of the sphere will be there. So you will find that this sphere is not touching this particular portion, that is, it is not touching this point, but this sphere is practically resting at this point. But why does it appear to be moving forward little bit? The reason is because this surface, you can see this surface is also inclined. So when you look at this inclined surface, so even though the sphere is touching at a point of its, you see 1 over 1 of the points on the circumference at the center of this cube, but when you look at it from the top, you will feel that this sphere has been displaced by a shorter distance towards the observer over there. Whereas practically and actually and ideally, this sphere is resting at this point, one of the points on the circumference at the center of this particular cube. So what we need to do whenever we have to draw sphere on top of anything, the radius which will be used to draw this circle will be the isometric radius. So this is the isometric principle which will be applicable to the sphere. That is, always you will find that even though the sphere will be resting on any given solid at the center point, but it will appear to be projected or shifted little bit towards the observer over there. So what we have to do, we will be marking this radius which we have to take to locate the center of the sphere. This distance being a linear distance, this will be marked as an isometric radius over here. And once you mark the center of the sphere, the radius of the sphere will be the actual one, because no foreshortening of the dimension of the sphere will be there. So the shape of the sphere will remain the same, and the size of the circle will also remain the same. So while we go about the construction of the circle over here, so we will find that in the isometric projection, this circle will appear to be moving forward over there towards the observer. So this is the isometric projection of a sphere which is resting on top of a cube. So you can see the diameter we have drawn as phi is equal to 40 millimeter. That is, the sphere circle is going to be radius of 20 millimeter. So always for a sphere, we have to draw this radius to be isometric while locating the center. And once the center is located, now you open the actual radius. Now you open the actual radius and you draw the circle over there. So no distortion in the projection of the sphere has been observed over here, right? So this is the special case of a sphere which is resting centrally on top of a cube. So even if it is resting on top of a hexagonal prism or a pentagonal prism, the same principle will be followed all over the place, right? Now whatever portion you see of this particular top face of the cube has been covered by the sphere, so that will be left as construction line, right? So no hidden line will be drawn. So this portion will be left as it is as a construction line, but whatever remaining portion of the top face of the cube is there, so that will be darkened, so that now we have completed the construction of a sphere which is resting centrally on top of a cube, right? So now next let's move on to the isometric projections of a square block which is resting on top of a cube. So we have to draw the isometric projections of a square block of edge 30 millimeter and the block height will be 20 millimeter, which is resting centrally on top of a cube having edge equal to 50 millimeter. So now once again we start with construction of the isometric scale and then draw the cube. So cube, we know by now how to draw the cube isometric projection. So you see we have marked this cube over there, height is equal to 50 millimeter, the dimension along the z-axis, this has also been marked to be 50 millimeter, and then dimension of the edge along the x-axis has been marked to be 50 millimeter. So once we complete the front two faces construction, then the top face, once again we are not going to join these two edges dark. Why? Because now a square block will be resting on top of this cube. So certain portion of these two edges of the cube will be covered by this square block which I am going to draw over here. Okay, so this is my complete construction of a cube, and these two edges I have left deliberately lighter so that whatever portion of the square block will be covering the edges over there, so that portion of these two edges will be left light and the remaining portion I am going to darken thereafter. Now let us see the height of the square block is given to us as 20 millimeter, and you see the size of the square block, it is 30 millimeter. So what I need to do to locate this square block centrally on top of this cube. So how much is the dimension of the cube? 50 millimeter. So please check. This edge of the top face of the cube is given to me as 50 millimeter. This edge of the top face of the cube is given to me as 50 millimeter. But the top of face of this particular cube is being placed with a square block of having edge 30. So 30 means you have to take out the center of this particular top face. You see, I have taken out the center of the top face over here. So once I take out the center, and how do I take out the center? Please check. Take this dimension and mark 50% bisector of this. Take this edge and mark the bisector point of this particular edge. Draw this axis line over here. Similarly, take this edge on the top face of the cube, mark the bisector. Take this edge on top face of the cube, mark the bisector or the midpoint, draw another axis line. Now once I obtain the axis, now the edge of the square block happens to be 30 millimeter. What I'll be doing? Please see. I'll draw a horizontal locus line or a projector line or a construction line parallel to this axis line, displaced by 15 millimeter on this side, 15 millimeter on this side. So one construction line over here, one construction line over here at a distance of 15 millimeter and 15 millimeter from here, so that the distance between these two projection lines will be 30 millimeter. Similarly, parallel to this axis line, I will be drawing another construction line over here and one more construction line over here, so that distance between this construction line and this construction line from the axis will be 15 millimeter each. So that total distance between the two edges will be 30 millimeter. So please check the distance between this construction line and the axis line I have taken to be 15 millimeter, and distance between this axis line and this construction line I have taken to be 15. That is, total length is 50. So I have divided it into 4 parts: 15, 15, 10 and 10, right? So 10 mm I have to leave from either side. Okay, similarly you leave 10 mm from this side, draw a construction line. You leave 10 mm from this side, draw a construction line. So two construction lines are available which are at 15 millimeter on either side of the axis over there. Okay, so here also 10 millimeter from here, 10 from here you leave. So this is automatically 15 millimeter from the axis and 15 millimeter from the axis. Now you see, I have been able to draw the base of the square block. This is the base of the square block, and just like in the case of cube, what I will be doing? I will be joining this dark 30 millimeter. I will be joining this dark 30 millimeter. Then the height I will be taking as 20 millimeter. Height of the square block is given to me as 20 millimeter. So now I am going to start with the construction of a square block. So square block is similar to the cube. Only difference is the height component. It is not equal to the edge length. It is equal to whatever height is given to me. So please see, this height I have taken to be 20 millimeter. Had I required to draw another cube on top of it, cube over there, I would have required this height to be 30 millimeter. So now I am taking this height to be equal to 20 millimeter. So this edge length, vertical height, it is equal to 20. So same I apply here. Draw 30 millimeter, draw 20 millimeter height, draw 20 millimeter, just like this cube. Now this top face will be now visible to me. Now I will be drawing the top face of the square block. Now you can see we have drawn the construction of the square block, in which you can check the base was a square, the top is a square, but the base edges you can see we haven't darkened because these base edges, they have been covered by this face and the top face. So if you consider this to be front, so these two edges of the base, they have been covered by front face, side face and the top face. So that is why these two have been just joined by lighter lines or the thinner lines over there. Now this is the construction of a square block having the edge, you can see 30 millimeter, having the edge 30 millimeter, height 20 millimeter, resting centrally, it is resting centrally on top of a cube having dimension 50 millimeter over there. Right, now we move on to the last case for today's lecture, that is an isometric projection of a cone is to be drawn having diameter 30 millimeter and axis height of the cone should be 40 millimeter, and it is once again resting centrally on top of a cube having h is equal to 50 millimeter. So once again a cube I will be drawing. So first of all the isometric scale will be drawn, and all the dimensions which are given over here, they will be converted to the isometric length dimensions. Only then they can be plotted onto the isometric projection of the combined solid. Now once again we begin with drawing the basic horizontal locus line or the ground line over here. This is our horizontal ground line. Then at an angle of 30 degree on either side, our x-axis and the z-axis will be located, and the y-axis will be located along this particular vertical direction. Now along the z-axis I have marked the edge of the cube which is equal to 50 millimeter isometric length. Then the vertical h has been drawn over here once again on the y-axis, and its height will also be equal to 50 millimeter. And then this is the isometric edge. This is again the isometric line or the isometric edge corresponding to the front face of the cube which is visible to the observer. Now the side face will be drawn. In the side face, once again the edge will be drawn on the x-axis over there. So on the x-axis we have drawn the edge of corresponding to the base of the cube. then the vertical edge corresponding to the side face, and this is the inclined edge which will be parallel to the isometric axis. So the two faces of the cube we have been able to draw. This is my front face, this is my side face of the cube. Now the top face will be drawn, but once I complete this top face by drawing two edges parallel to the isometric axis over here, another one will be parallel to this isometric axis. But if I draw them dark, now ultimately I have to draw a cone on top of this. So these two edges, certain portion of these two edges will be covered by this cone, which is going to rest centrally on top of this particular cube. So I cannot draw these two edges dark at the moment. So the lighter edges, they have been drawn to begin with. Now how do I draw a cone on top of this? So once again, the center point will be located, and depending upon the dimension of the diameter of this particular cone, so I have to locate a square block on the top of this, as we had done in the previous problem. So you see, we have to draw a cone having a radius of 15 millimeter or a diameter of 30 millimeter resting centrally on top of this particular cube. So you cannot draw a circle straight away over here, and we know that circle appears to be an ellipse in the case of isometric projection, and in order to draw the ellipse, the four center method will be required, as we have already discussed this method in the previous lecture. So again we are going to go through it briefly. So please see, we are going to inscribe the circle in a square. So circle can be inscribed in a square, and this square of 30 millimeter will be resting centrally on top of this particular top face of the cube. So once again, we have located the center point along x-axis and along the z-axis over here. So this is the center point along this axis, z-axis. This is the center point along the x-axis. Now please check, get the bisector of this edge, get the bisector of this edge, mark 2 points, join them through the axis line. Similarly, get the bisector of this edge, get the bisector of this edge, again mark another point and join these two bisectors. This will give you the center point of the axis. Now I have been able to find out the central point over here. So I know that this square, which should be resting over here on top of this, it is having dimension 30 by 30. So please see, with respect to this axis and with respect to this axis, I am going to draw two construction lines which will be at a distance of 15 millimeter from the axis over there. So along this axis, two construction lines have been drawn 15 millimeter away from the axis. So once again, we have divided this top face of the cube, which was 50 millimeter, into four parts. You leave 10 millimeter from here, you leave 10 millimeter from here, so automatically 15 millimeter from the axis will be available, and again 50 millimeter from the axis will be available. So the total distance between these two construction lines will be 30 millimeter. Similarly on the other side, please check, this is 30 millimeter, right? So again we have drawn two construction lines which are spaced 15 millimeter on either side of the axis. So this is 10 millimeter, this is 15 millimeter, this is again 15 millimeter, and this is again 10 millimeter. So what we have obtained, please check, we have been able to obtain the location of a square block. This is a square block on top of the top face of the cube over there. This is the top face of the cube. So on the top of the top face of the cube, we have been able to locate and position a square block which is centrally located. Why do we say it is centrally located? 15 from here, 15 from here, 15 from this axis, 15 from axis. So this square is located centrally, and we know that the square appears to be a rhombus in the isometric projection. So now we have obtained a rhombus over here. Now this rhombus will have one minor diagonal, this is minor diagonal, and one major diagonal. So this is the major diagonal of the rhombus, right, or a square. So this is the major diagonal of a rhombus. square as it appears onto the isometric projection will be a rhombus. This is the minor diagonal. So as we have already discussed, from the two corners of the minor diagonals, we need to join the midpoints of the opposite edges of the square over there. So please see, from this corner of the minor diagonal, I have drawn the projection which will be joining. This was the midpoint of this edge. So I have joined the opposite bisector points of the opposite edges over there. So from this corner, these are the two opposite edges. So this is the bisector of that edge, that particular edge, this one. So join it. Similarly, this is again the opposite edge, opposite to this minor diagonal corner. Again join it with the help of a projector line. Similarly, through this is the second end of the minor diagonal. From here, you have two opposite edges, these two. These are the midpoints we have already marked. So from here, you join this midpoint. From this point, you join this midpoint. So this is the four center method. Now, with this construction, all the four centers, they have been located. What are those centers? Now you check. This is center number 1, center number 2, center number 3, and center number 4. Please see center number 1, C1, center number 2, C2, center number 3, C3, center number 4, C4. So from this center, please check. Open this much curve or open this much curve. Draw an arc using the compass. Using corner point second as the center point C2, open this much compass or open this much compass. So with this as center, draw another arc using the compass over there. Using this center, center 3, open this much compass or open this much compass. With this as center, draw the third arc. With this as center, center 4, open this much compass or open this much compass, and then keeping this as the needle point of the compass, draw the fourth arc. So all the four arcs can be drawn using the compass over there. So this is a perfect ellipse which has been obtained. And now we are going to draw the axis point. How much is the height of this cone? 40 millimeter. So from the center point over here, I am going to measure 40 millimeter isometric length. So please check. With respect to this center, I have measured this axis length is equal to 40 millimeter. So this axis length, I am going to mark it over here. Please see. This is my axis. I will mark 40 millimeter. So apex point O of the cone will be located over here. And once this apex is located, draw the tangent, draw the slant generators to join this particular ellipse as a tangent over here. So from this point O, draw two tangents on the either side of this ellipse. Basically, this is a circle which is appearing like an ellipse in the isometric projections over there. Now, having drawn these, now we can join the things dark, and once again you check this portion of the ellipse which is lying on the back side, which has been covered by this surface, will not be drawn dark. So no hidden lines once again. Okay, so I am going to now join these two slant edges dark. This portion of the ellipse will be joined dark, and this portion of the top face of the cube will be joined dark. And this is your apex point which we have shown over here. So this way we have completed the discussion regarding the construction of a combined solid in which a cone is resting centrally on top of a cube, right? So this is all about the discussion regarding isometric projections of various solids which are having one major common element as a cube over there. So 4 problems we have been able to discuss today in this lecture. So this is all for today. So we'll be continuing with further discussion regarding few more shapes of the solids to be constructed in the isometric projections in our next classes. So thank you very much. Thanks a lot.